All right. Good morning, good afternoon, everyone, depending on where you are. My name is Steve Cramey. I am a Director of National Accounts and Distribution for Avanos. I am pleased to be able to bring some of my colleagues that are members of GEDSA, including our Executive Director, Ben Davis, who I'll let him introduce himself in a moment. The purpose of this call was an educational webinar on ENFit and NRFit. And I'll let Ben kind of walk through his role within the organization as the executive director of GEDSA. And we also have Madison Webb on, who is also a member of GEDSA. And together with industry sponsors as well as advocates, our goal is education around not only the ENFit connection, which I'm sure many of you are familiar with, but also what is going to be forthcoming with NRFit. So again, I will turn this over to Ben, who's going to be leading discussion moving forward. And thanks everyone for joining today.
All right. I guess you can now see my introductory slide here. Well, welcome. Today we'll be discussing improving patient safety through safer tubing connections.
And the other one.
This is, as Steve said, basically presented by GEDSA. GEDSA is the Global Enteral Device Supplier Association. We're a nonprofit trade association made up of about 40 manufacturers, 30 or so supporting organizations, and then also we have different clinical groups that we also are involved with. For myself, I'm Ben Davis. I'll be presenting this material today. I'm the executive director of GEDSA. I've been involved with GEDSA since, I guess, 2012, and over the years I've served on various committees, and then was on the board of directors prior to becoming the executive director. Over those years, the way I was involved with GEDSA is because I was a member of GEDSA as being a part of the NeoMed company. I was the vice president of engineering and product development at NeoMed, which is actually now part of Avanos. At NeoMed, I led the development of their ENFit product portfolio, so I'm quite familiar, I guess you'd say, with these ENFit products. And I'm also an industrial engineer from Georgia Tech, and I have 13 years of medical device engineering experience. So I don't know, I think the competency level here among this group is pretty high today. So you may see some of the stuff where I kind of come at this stuff with a little bit more of a technical, maybe perspective on it, because that's my background. And it is a lot of material to cover ENFit and NRFit. So I'm gonna go pretty fast because I think there is a high level of competency. We'll have a Q&A session at the end. So if you would, please try to hold your questions and we'll come back to those. Our agenda for today, well, the main goal is to raise awareness of tubing misconnections and the enteral ENFit ISO 80369-3 and neuraxial NRFit ISO 80369-6 patient safety initiatives. We're going to do this in 4 modules. The first one is, well, we're going to talk about what is a misconnection. So we have a good foundation. The second module, we'll talk about the impact of misconnections. And our third module, we'll talk about how to reduce those misconnections with ENFit and NRFit. And then there, we'll also kind of get into a device overview, where we'll see some of these impacted products. And then in the fourth module, we'll talk about conversion planning, resources that are available, and then we'll end with a Q&A session. So module 1, well, what is a tubing misconnection? Well, I like to start with this image. This is a sort of a recreation that the FDA did. This particular one is of a epidural tubing that's erroneously connected to IV tubing. Of course, that should not happen. This link, and I think hopefully this presentation will be made available to everyone afterward, but this link goes into the FDA's website, where they have maybe a dozen or so different real world case scenarios of misconnections where they've gone in and sort of recreated them using dummies and, set up equipment like this to kind of show how the misconnection occurred. So that was it sort of visually, but let's really get into defining a misconnection. And I like to use the World Health Organization's definition. It's a bit lengthy here, but I like to read it because I think it's a great definition of a tubing misconnection. They say, tubing, catheters, and syringes are a fundamental aspect of daily healthcare provision for the delivery of medications and fluids to patients. The design of these devices is such that it is possible to inadvertently connect a wrong connect the wrong syringes and tubing, and then deliver medication or fluids through an unintended and therefore wrong route. This is due to multiple devices used for different routes of administration being able to connect to each other. Of course, tubing misconnections can lead to serious injury or death. So these are very serious. I like to show this image to the right because this is a tiny little neonate's hand. So just imagine how small that is. And in this really tight space, we have 4 different types of tubing all in this tight space. And they basically all have either a lure or a needleless port connector. So there's a high level opportunity for a misconnection to occur. So I think this is a good visual of how this can happen. To get into some of the examples, so this, I said the FDA had maybe 12, maybe 15 or so different ones they list on their site, and they have a recreation, again, linked here below. But just to kind of go over some of these, to kind of get your head around what some of these we're talking about. In one case, and these have all actually happened. These are all based on real misconnections that occurred. In one, we have a epidural infusion set that was connected to a peripheral IV. This ended up delivering epidural medication to the bloodstream, resulting in the patient's death. In another case, IV tubing was misconnected to a nasal cannula that was used to deliver oxygen, and the patient survived but had congestive heart failure. Another case, the feeding tube was connected to an inline ventilator suction catheter, delivering feeding contents into the patient's lungs. This resulted in the patient's death. There's another case had a heparin lock connected to an automatic blood pressure cuff. This delivered air to the bloodstream, causing death. And then in another case, there was a feeding tube was coupled with a peripheral line of a pregnant woman. This resulted in enteral nutrition being delivered directly into the bloodstream, and unfortunately killed the mother and the 35-week-old fetus. So now that we've defined what a misconnection is, and we've seen some case studies or some actual misconnection events, well, how common are misconnections? Well, back in, let's figure out how far does this problem actually go. Back in 2006, the FDA and Aspen coordinated a survey. They ended up getting 182 responses on the survey from clinicians that included nurses, dietitians, pharmacists, physicians, safety officers, and the such. Of those 182 respondents, 15.9% stated that they had a misconnection at their institution. That's, to me, a pretty high number, but if you think of it in terms of the number of institutions across the country, so basically extrapolate that out over the 7,250-ish hospitals in the U.S., that would mean that 1,150 of those institutions would have experienced a misconnection. So in those kind of terms, it's just crazy. It's like unfathomable that meant, this it's just occurring. And unfortunately, what we see is that a lot of these go underreported, misreported, miscategorized, when they're reported. So that's why I think a survey like this is important. We're actually in the process of issuing out another survey to kind of update this information, but what ends up actually getting reported is not nearly as high as when you send out an anonymous survey asking people how many of them have experienced a misconnection event. But to get into the actual cases of misconnections, in 2010, a literature review was done. It was called Tubing Misconnections, Normalization of Deviance by Simmons et al. In that literature review, they identified 116 cases of tubing misconnections. Of those 116, 21 of the patients died. 95 survived, but 84 of the 95 had pretty severe complications associated with the misconnection. That was sort of enterally focused. Now looking at the neuraxial side of things, how many cases have been in the literature? About 2 years ago, this article was put out by Vescusi et al. And they looked at a 20-year period. So from 1999 to 2019, it was the only window that they looked at in the literature. But in that window, they found 133 cases of neuraxial misconnections. And of the 133, 26 resulted in patient deaths. And just to get a little bit more into how it broke down. The epidural medications were administered by IV lines in 29.2% of the cases, and intravenous medications were administered by epidural lines in 27.7% of the cases. I say that though because it explains that it can go either way. So it can be IV into epidural or neuraxial, or it can be neuraxial epidural into IV, because they're both Luer connectors. So it's a lot of opportunity for a misconnection to occur, especially in the neuraxial space. Now that we've talked about, we've defined a misconnection, we've looked at some cases. Let's talk about how do they actually occur. Well, it could be due to a multitude of things. It's, sometimes it could be attributed to low lighting. Could be that there's multiple device types and multiple lines. Human error, time pressures. You have off-label or unintended use of tubes. You even have patient portability and nursing turnover. So if a patient was at one facility that used one system and then they are on vacation or whatever and go to another facility that uses another system, that increases the risk. And same thing with nursing turnover. Since COVID, I've read an article that the amount of traveling nurses has increased about 300% since COVID. So again, a lot of opportunity where if a clinician is experienced with a particular hospital that had using one system, and then they go to another hospital that uses an entirely different system, there's learning curve there, and that increases opportunity for a misconnection to occur. But what's sort of central to all of these, or what is the root cause, if you will, is the compatibility of the connectors. So as long as you have a mechanical compatibility, you have a misconnection risk. So in order to minimize misconnection risk, you have to solve the mechanical compatibility. And why do we have that mechanical compatibility? Well, it's really due to the success of the Luer connector. And this is not a knock against Luer. It's a fantastic connector. It's too good. That's why it's been used so universally over the years. At one point or another, it's probably used in every medical device application imaginable. But that being so good and becoming so universal, that's what created a lot of these risks of the misconnections that we see. And Luer's been around for a long time. It was invented in 1896 and patented in 1897. And then they had the Luer lock came out in 1930. So when we talk about switching to ENFit or switching to NRFit, this is truly a paradigm shift. We've not really seen a standardized connector change since the Luer was actually invented. And then over the years, it's been better and better standardized. But really, as far as a new technology, it's been over 100 years. And I like to share this image because it's just the original patent where they filed for the Luer syringe. And it's just a rendering of a Luer connector, CAD rendering. All right, and that gets us through Module 1. The key takeaways in Module 1 is that tubing misconnections can lead to severe consequences, including patient death or serious injury. Misconnections are relatively common. Cases are reported in the literature, but the true occurrence is believed to be much higher because misconnections go unreported or they get misreported, miscategorized when they are reported. And then universally used, or if you will, cross-application connectors, particularly the Luer connectors, have contributed to the risk of tubing misconnections. And I just had this little image here in the corner because sometimes when folks tell me that, or they start wondering, well, can a misconnection really occur? And this is just an easy one to demonstrate. It's an extension off a low-profile device as a funnel connector. And then this is a 3 ml Luer lock syringe, and they make a perfectly sealing connector. It's not intended to connect that way, but it has happened where it's just an easy way to demonstrate a misconnection. Or that's what one, I guess, looks like, you could say. All right, so now that we understand what misconnections are, how common they are, why they occur, let's talk about the impact of misconnections. So, all that we just discussed can be somewhat sort of abstract. It really kind of boils down to it's like data, stuff that's found in the literature, and but I don't want it to be abstract because these are real people. These are real loved ones, real family members that have been lost. So I like to share this video that really kind of brings that back around to show that these are real people and that this And it's very unfortunate when this happens.
I didn't get to say goodbye. And she said, "Oh, honey, I'll see you tomorrow." I said, "I know, Mom, but I just want you to know I love you." She said, "I love you too."
It's so important that we take the time to make these changes.
Yes, this is a big deal. It's huge. It is huge to change all the tubings in all the hospitals. There's a reason for it. This can't happen.
My name is Trisha Ostad. I've been a registered nurse for 32 years, mostly in the areas of critical care. Of course, always focusing on quality care in a very safe environment. On June 5th of 2012, my mom went into an outpatient surgery center to have carpal tunnel surgery done. My mother had the procedure done under a local, no general anesthetic, came into the recovery room. The nurse took the line from the blood pressure monitor, and instead of inserting it into the cuff, she inserted it into a port of my mother's IV. This particular blood pressure machine, when you hit the button, would attempt 3 times to get a blood pressure reading before it would give up. So the large amount of air that would have entered into the cuff to create a reading went into my mother's bloodstream 3 times. That explains why she was gone within a minute of arrival, because she just died from a very massive air embolus, and that explained her terrible presentation in the emergency room.
My name is Johanna Back, and our daughter was on the receiving end of a tubing misconnection in 2006. She was born at 30 weeks. She has Down syndrome and duodenal atresia, so she already had some issues. Plus, she needed to have an open heart surgery. She was in the NICU for a while. While in the NICU, a nurse attached her G-tube line to her IV line. When the nurse realized her mistake, she yanked out all of the tubing. And I'll never forget how she looked that day. They didn't think she was going to make it. They finally got some lines in, and they just did all they could do to support her. It took 3 days on life support, but she did make it through. We were very lucky that she did make it through, because most people don't make it when this happens to them.
My name's Glenda Rogers. I've been an OB nurse for 26 years. My daughter Robin was 35 weeks pregnant when she was admitted to the hospital with nausea, vomiting, dehydration, and pain. The doctors caring for her had decided that she needed to be transferred to a higher level of care. But before they would transfer her, they wanted to check on the baby. They did the ultrasounds and checked, and there was no heartbeat, and we had to tell Robin that the baby had died. Before the transfer was completed, Robin also died. On her IV pole, there was a bag of, the best way I can describe it is it looked like a melted chocolate milkshake. A big bag, like 2,000 liters. And on every corner of that bag, it had not for IV use. And it was hooked to her PICC line. The tubing was compatible with the PICC line, so there was no trouble hooking it up. She started it at 11 o'clock to run at 200 an hour. It wasn't discovered until 5 o'clock that night.
stop that there. Of course, it's very hard to watch, but hopefully it does what it's intended to do, which is really kind of personalize this and make it, bring it back to reality that this is, this happens. These are real people and people's loved ones that this has happened to. That video was really focused around some integral misconnections, but since today we're talking about neuraxial as well, there are, it doesn't take much effort to look through the literature and search some of these, but there are a multitude of cases that are also out there in the neuraxial space. A lot of this was covered in the literature review that I mentioned earlier by Vescusi. And we don't have time today to kind of go through or summarize these, but this is just to show that there are quite a few, probably actually by the numbers, I guess more really in the neuraxial space. So clearly we have a problem. It's a real problem, but how do we solve this problem? Well, over 10 years ago, a global effort was started by the ISO group, which is the International Organization for Standardization. They created a series of standards called the ISO 80369 small bore connector series. That group is made up of technical experts, clinical experts, and then regulatory and standards experts. The sort of the main I guess, drive or goal of that effort was to make mechanically engineered connectors that were incompatible with other areas of therapy, so that no connectors within the series would cross connect with one another, to really try to minimize the risk of a misconnection event occurring. Of course, today we're talking about the integral section, which is ISO 80369-3, which is more commonly known as ENFit, and then the neuraxial section, which is ISO 80369-6, and that's commonly known as NRFit. Now, those are the two we're focusing on today, but those aren't the only two. And so while we're here, just to show you, it's actually the other sections are -7, which is the IV, basically. Interestingly enough, we just talked about the lure, and it's a great connector. We don't want to abandon it. So it's actually the connector that's in -7. It's just as part of this ISO standard. It's, some of the criteria and wording and all has been harmonized to fit in with the other standards. But, if you're using a lure syringe, which you most likely are, you're using an ISO, you're using a connector that's part of the same series. Other sections, we have the limb cuff. One of the cases that we saw in the video was a limb cuff misconnection. That's the -5. This urinary is -4. That one's sort of on pause at the moment as the working group is still sort of working on that one. Then the other section is the respiratory, which is the -2. So it's really all these bodily systems that use small bore connectors. And then just to kind of get some time frames on it, this just shows when these were actually published. So these aren't new. These have actually been out, and some of these have even been had a revision come out to where every so many years ISO standards go through a revision process. So some of these are on like the second edition. A common theme though across all of these, the general requirements is that these are not connectable with other connectors in the series. The connectors are rigid, must be rigid or semi-rigid. So if you think about some of the funnel connectors, like in the integral space, they're very pliable, they're soft, they're able to flex and seal around items that they shouldn't. So every one of these connectors in this series of standards has a hardness requirement where they don't flex like that. They must also all pass misconnection risk assessments and usability and human factors testing, and of course they must not be compatible with lure or needleless connector ports. So our key takeaways for that module are that misconnections have a significant impact on patient safety, and they can occur due to various factors, but the root cause really is the mechanical compatibility of connectors. ISO design standards have been developed for system-specific applications, ensuring that connectors are not connectable with others in the series and are not connectable with lure or needleless connector ports. And the ISO standards implement a incompatibility by design connector features to prevent misconnections and improve patient safety. So basically, if it's not clear, we dedicate through this series of standards, each application has a dedicated set of connectors that does not work with another application, any of the other applications. Okay, now that we've given sort of a highlight of the series, we're going to dive more into the specific sections that we're discussing today, which is the ISO 80369-3, that's ENFit, and we'll discuss its components so that we're all well versed in what products we're talking about. And then we'll also go into ISO 80369-6, which is NRFit, and we'll kind of give an overview of its components. And then we'll wrap this section up with a comparison, so we'll kind of lay out the syringe types of we'll go ENFit, oral slip, Luer, and NRFit all together, so you can see sort of what the differences are sort of in one shot. So the enteral specific standard, which is ISO 80369-3. Of course, we call this ENFit because it's not nearly as hard to rattle off. I like to share this image here on the right because this is straight out of the standard. This is the engineering drawing in the standard. I like to share this because I don't think people realize just how dimensioned these connectors are. I think each, this is the feeding tube side connector. There's also a drawing for the syringe side connector, and I think each of them have 22, I want to say, dimensions, and these are, so it's heavily dimensioned, and then all these dimensions too are very tightly tolerant. So it's a very exacting, not the easiest to manufacture parts out there because they are so exacting and rigorous. These have all gone through, I mean, the male and female ENFit connectors have gone through misconnection risk assessments that have been scrutinized by the FDA and other regulatory agencies throughout the world, where they passed that rigor. These connectors have been on the market in the US and Europe since 2016, and Europe has been at nearly 100% conversion since probably 2018 or 19. I don't say 100% because statistically there's always going to be an outlier to where I don't know that you ever hit 100 on any population size that's large. But and I also want to say that since it's launched, the safer ENFit connectors have not had a single reported misconnection event that was attributed to them. So if you go digging around, you may find reports of misconnections and ENFit may be mentioned in it, but I want to explain what that is because the instances I've read, which aren't really many, is a situation, and I'll use an example, but this is kind of indicative of the 2 or 3 I've seen. It's where, like, I think one instance was a IV syringe with the IV medication was brought up to the floor, and the nurse tried to administer this into an ENFit connector. She could not make the connection because ENFit did its job and the connection could not happen. However, the clinician then took the syringe, the IV syringe, Luer connector syringe, emptied the contents into an ENFit syringe so she could make her connection, connected it to the ENFit feeding tube, and made the connection, and inadvertently or made the medication administration error. So that somewhere out there, it's in the literature, but it's not. ENFit really actually did its job. The whole safety mechanism circumvented. So you may, as time progresses, you may see a case here or there, but please read the detail, sort of read in between the lines, because I think you'll find that it's not actually a misconnection that occurred because of the connector. Now we'll go through the components. I'm going to go through these fairly quickly because I think you're all pretty well familiar with these, but just so that it's clear for anyone that's not. Within the enteral system, we have 4 main components. You have administration sets, syringes, feeding tubes, and you have pharmacy and accessory items. In the administration sets, you have different types of administration sets. You have bag sets for pumps. You have gravity sets, extension sets. There's other bolus feeding devices you have. I want to mention while we had this image up that back about middle of last summer, some manufacturers started removing this transition connector, this little white piece you see on the bag on the left, from their assembly to where now the assembly looks like the configuration on the right. Manufacturers still have these available as a standalone item, but they've started removing them because as we transition to NFit, it's not necessary and all. Basically, there's a lot of waste throwing these things away for folks that had transitioned. So now they're offered separately by most manufacturers. If you're not familiar with what part we're talking about, this is a transition connector. Some call it a Christmas tree connector, some call it a step connector. We call it a transition connector. On extension or administration sets, one thing I do want to mention is for low profile extensions, the bayonet or key, like from a mid key connection is not actually changing. So for a low profile device, the part that goes into the low profile device is not changing. It's the other end. So here where the funnel connector is on the right will now be an ENFit connector here that's on the left. The next component really in the enteral system is our syringes. Over the years, just historically, we've had all kinds of syringes that have been used in the enteral space. This image just is to show the multitude of different syringes that have been used. Part of the problem is that other than the ENFit syringes in this picture in the lure, none of these other ones are standardized and some of them are proprietary. For the sake of time, I won't go through all these, but you can see these later and sort of break these down. Within ENFit, I do want to mention there are two syringe tip types. So for your larger syringes, like usually 10 ml and larger, you'll have a standard ENFit syringe tip that's on the right here. And then for your smaller syringes, usually 6 ml and smaller, you'll have what's called a low dose tip, which is this nozzle in the center, which is there to increase the dosing accuracy of these smaller volume doses. Moving along, the next and the sort of piece or connection within the enteral system is our feeding tubes. These are, of course, come in many shapes and sizes. We have gastrostomy tubes, low profile tubes, NG, NJ, GJ, PEG. And this image here, it's this sort of a crosswalk showing, well, the ENFit is on the left, and then this is what the legacy product of the exact same manufacturing configuration was on the right. Same in the bottom image here, ENFit, the purple on the left, and then the legacy version was on the right, just to give you an idea. Our G tube, same thing. We have our legacy on the left, and then ENFit's on the right. So you can see how the connections are changing. Our low profile devices, these are not changing. So this is what I mentioned before with the bayonet fitting, the extensions that go in these are not, that connector is not changing. So you don't have to worry about low profile devices. And this is how they come together. Of course, it's a twist connection. So here an ENFit syringe is twisted, screwed into a ENFit feeding tube. There's a syringe into the extension and the extension into the low profile device. And then to sort of round out our enteral system, we have pharmacy and accessory items. So within this scope, there's like medicine bottle adapters, fill straws. You have these press-in bottle adapters with ENFit connectors. As ENFit sort of rolled out, we realized that there was sort of a gap in, I guess, the pharmacy awareness and education. So we developed a pharmacy guide. You can go to that in this link below. It's really meant to give end users, pharmacists, clinicians, pretty much anyone, because it's very high level, sort of a visual crosswalk to say, if this was your legacy product, over here is there is an ENFit version of it to make your life easier, and here's how to find it. So I encourage you to check that out if you've not seen it. And this is just another image of how these things look up close and how they fit within that diagram we saw earlier. Now, and I'm trying to move faster, but I like to close it out with this image just to kind of emphasize this is not like, we're not talking about a syringe or a feeding tube, that's changing. This is like portfolios. This is the whole enteral systems that are changing. So entire product portfolios. And this image just has, I think, demonstrates or illustrates the number of items that can be impacted. Moving along, we'll now discuss the 80369-6, which is the NRFit, neuraxial standard. Again, this is the drawing straight out of the standard. It's heavily dimensioned and very tightly toleranced. This too has gone under misconnection risk assessments that have passed the rigor of and scrutiny of the FDA and other regulatory agencies. It's been available in Japan and Europe for several years. Of course, they have a different regulatory landscape. And Japan's actually been 100% converted for, I think, a little over a year now, or maybe right at a year. Same thing I mentioned with ENFit. with NRFit, not heard of any reports of a misconnection event that was attributed to the NRFit connector. NRFit will connect with NRFit, but Lure will not connect with NRFit, and NRFit will not connect with Lure. That's what this image shows. Then this is a short video, but gives you a nice sort of background or high level understanding of NRFit. And I'll mention real quick, it said look for yellow. Color is not a requirement of any of these ISO standards. Manufacturers generally kind of migrate to a color selection, but color is not really a risk mitigator for a misconnection, so it's not part of the standard. Like I said, a lot of the manufacturers are aligned to a color for an application. Not to go into every little micro application here, but just high level, the devices that are impacted by ISO 80369-6, NRFit, you have your epidural and spinal applications, you have your major regional anesthesia, continuous wound infusion, and then there's equipment for specialist training. And then to visualize some of these components, you have slip tip syringes. Here you see your Lure version. Your NRFit version, the nozzle is a little bit smaller, but has the same ID. And it actually has a collar around it, so you won't see an exposed tip like you have with the Lure slip. There's also the locking syringe. So you have a Lure lock, and it's just shown in that video, the NRFit lock, the nozzle does not protrude past the collar. Then you have your loss of resistance syringes, and same thing, you can see how the nozzle does not protrude past the collar on the NRFit version there on the right. You also have bacterial flat filters. The previous slide was all male connectors. This slide just happens to show all female connectors. You can see that the Lure is a little bit larger than the NRFit connectors on the right. Epidural needles are also part of this, and so are spinal needles. And then we have our catheter connectors, where these clamp down on the catheter tubing. And then you also have filter straws. And you can hopefully see across these pictures the slight sort of dimensional differences. And then to just lay them all out sort of together so you can see the differences. Here we have a ENFit full thread standard tip. So another thing I wanted to mention is within ENFit, you can have a full thread syringe or a partially threaded syringe. So syringe B is a partial thread. They're both ENFit. They're both 100% within the standard and acceptable. But just depending on who your manufacturer is or what the application is, it may be full thread or it may be partial thread. B is also, you can see within it, has a low dose tip. C, just for comparison, side by side here is an oral slip. D, you can see how a Lure slip sort of stacks up against that. E is a Lure lock, and then moving into NRFit, we have our NRFit lock with F, and then NRFit slip with G. Key takeaways here is that the ISO 80369-3 is the enteral specific connector, better known as ENFit. We went over the components there: administration sets, syringes, feeding tubes, pharmacy accessories. ISO 80369-6 is NRFit. That's the neuraxial specific connector. And of course, we just went over its applications as well. For time, I'll move on. Module 4, now to get into conversion planning and resources. It's usually like a three-tiered sort of, or three-step sort of approach. Usually starts with awareness, which is, your communication activities, then your prepare, that's your educational activities, and then the actual adoption, which is where you transition. Really, I mean, we have so many resources available. I could not walk you through every single one of them here, but if you would go to our website, we have so many items that are available. We have FAQs, we have transition checklists, we have videos, we have medication administration guides, we have cleaning protocols. You name it, we try to have it. So I encourage you to check our website out. But then to actually make this happen, one thing that's a very common theme is that it really takes a transition leader. This particular graphic here is more for the neuraxial side, because you see anesthesia and oncology and stuff here. But this is this is just helps to show just how many points of contact that you have to kind of coordinate with to actually implement a transition. So it really does take someone to kind of take the reins and step up and head a transition effort. To aid in that, we also have interactive teaching stations. You can order these through our website. We have ENFit version here. This actually comes in a pediatric or an adult version, is pictured, and they come with a bunch of product samples. So you kind of have some hands-on, ability with these connectors. A lot of times, I'm an engineer, so a lot of times when I have it in my hand, it makes perfect sense. So I like to tinker with things, so that it's always helpful to me to have them in hand. I think other people, it helps as well. We also have an NRFit, same thing. We have a toolkit. This is just the board display for it to show you we have it. And then to kind of get into, and I think everyone would like to know, where are we with this transition and this planning around the globe. For ENFit, our latest numbers are that we're about 60% in the US, approximately 45% in Canada. These are acute care conversion percentage numbers. Like I said before, Europe's nearly 100, Australia, New Zealand, sort of South Pacific, around 80%. South America is getting underway. We're actually going to the Braspen conference at the end of the month to speak and to hopefully gain some traction there. And then on the NRFit side, unfortunately, we're still at 0%. And there may be a conversion, but we're not aware of it. I don't think there is in the US. I think the reason behind that is to my knowledge, there's sort of some key products that are still awaiting FDA 510K clearance to be able to be sold in the US. If you look over here in Europe, they have different regulatory requirements, and they are converting all over the place. So UK is about 65%, hopes to be 100% by the year end. And I won't read all these off, but you can see all these other regions, countries and stuff in Europe that are converting. Japan's been 100%, and we have the South Pacific is also starting to convert. Key takeaways on this module is that there are a multitude of resources that are available for ENFit and NRFit. Please go to our website, stayconnected.org. We also have toolkits available. We encourage you to have at least, it's great to have one of those, at least one per facility, so folks can get hands-on, put the product in their hands and see it. And that these things are also global. So, I mean, this is not like, regional, like we're not isolating this to a state or a country. I mean, this is the global standard, and the transition's occurring worldwide. And then I kind of like just wrap things up to say, our members make presentations like this possible. So I just like to share, who makes up our organization. These are the manufacturers that are involved with ENFit. Here's our manufacturers involved with NRFit. We're partnered with these supporting organizations that we collaborate with, and we work together on these initiatives. And hopefully I have enough time for a little Q&A.
Hey, Ben, thank you so much. So I'll go ahead and open up for questions. Oftentimes it's a quiet group, so if we have any questions, please feel free to reach out, speak up.
Hi, this is Maggie. Can you guys hear me?
Yes.
Hi. So I actually put this in the chat as well, but so with the NRFit, the question that has come up here is that we both prepare and administer IT chemotherapy, with a closed system transfer device. And I apparently can't type it in the chat, but CSTD. So from what I understand, there is not one developed yet. Like this whole new requirement came about, and nobody really looked at a closed system transfer device to fit. Do you know of anything? Is there anything in the works? Because that's a whole nother, that's chemo safety.
Yes. So I've not heard of an issue with that. So I don't know if it's maybe a function of a different supplier having something available. As I showed in Europe and in Japan, we have conversions happening all over the place. So I'm assuming there must be a solution available. It could be that this is one of the product gaps that's in the U.S. that's still awaiting a 510K FDA clearance. But I'm happy to follow up with that and poll the manufacturers to see what is available or what will be available for closed system transfer devices.
Yeah, I think I spoke to somebody from ICU Medical who makes the one we use, and they said they were caught a little bit unaware, like the new standards came through and nobody had really sort of thought about that piece. So if there is something that's under development, because it's still chemotherapy, so we still have to do all this safe handling.
Yeah, and I do imagine it's probably a availability thing that's probably due to some regulatory issue. But I'll dig further into it. I think it's a great question and one hopefully I'll be able to get you an answer on.
Great, thank you so much.
Hi, Ben. I'm Ashley Shepard. I'm the Value Analysis Manager at the Children's Hospital of Philadelphia. So I'll say that the number one thing that's holding us back from ENFit conversion is the low volume, high risk safety events that are reported related to the inability of the tubing to become disconnected when tension is applied. So you're probably aware that in 2022, the FDA put out a strangulation risk warning for patients who are using ENFit connections at home after the death of 2 children who got tangled in their tubing overnight. We know that as we take care of children, they're wiggly, they twist, they turn. And if it's a tube that just goes down through their nose, and that gets yanked out, okay, you put it back in. But if there are kids that have permanent surgical tubes that go in through the stomach into the small intestine, and those get ripped out because there is no disconnect or breakaway device in this setup, that can cause significant internal injury. We've personally had a child at CHOP who had this happen at home. Caregiver tripped over the tubing. The tube was ripped out of the intestines. He needed weeks and multiple repair surgeries. So understanding that's not going to happen that often, but when it does happen, it's very significant. So I'm curious on the GEDSA end if there has been any discussion or collaboration with manufacturers on producing any sort of breakaway device that can be inserted along the enteral tubing that disconnects the system when a certain amount of tension is applied so that we can mitigate those risks.
Yes, I appreciate that question. And you make a wonderful point about the breakaway aspect. So ENFit ISO 8369-3 as being a twisting sort of locking connection, it will not or does not as easily pull apart or may not as easily pull apart as your legacy sort of socket and cone connections. However, a lot of those, you still almost have to twist them and apply a decent amount of force to actually get a lot of those to disconnect as well. But this has come up a few times. It's not very common, but we have, I try to discuss with the manufacturers issues and concerns we learn about and then try to encourage them and brainstorm on what solutions might be available. We have talked about breakaway features. I don't know if anyone's developing it. I think what's interesting about GEDSA is all our members are actually competitors to one degree or another. So I think sometimes they hold their cards a little close to their chest and don't want to maybe share. But I do, as an engineer, I certainly think there's a way we have other tubing sets that have breakaway features. So I think if someone desired that within ENFit and there was enough desire, I would hope a manufacturer would take that on and offer that. But I'll continue to poll and prod and ask that something like that be available.
Okay, thank you. I do think it would be helpful as kind of the organization that's championing this change, if there was some advocacy at that level for a breakaway device or a greater enhancement for these safety concerns.
Any other questions, concerns, comments? It's really good information.
Well, if not,
Okay, well,
I want to thank everyone. And again, just direct you to stayconnected.org for information. And two, we're available by email. Just email us at info@gedsa.org. We're happy to help you find materials, answer questions. We're here to help, and we're happy to help. So please don't hesitate to reach out to us.
thank y'all so much. You get 7 minutes back in your day.
Thanks, everyone.
All
Have a
right,
great day.
bye-bye. Thank you. Bye.